Hello and welcome back. Today we are going to discuss about Delta Live Tables. Delta Live Table is a declarative framework built by Databricks to make ETL processing or data processing pipelines easier. Now, what do you mean by this declarative framework? This declarative means that you have to only worry about writing transformations and not about the background working. DLT pipeline will automatically take care of the orchestration, cluster management, data quality, and error handling. So, as a developer, we can focus on writing the transformations that has to happen in a ETL pipeline and not worry about the background working. Now, one thing to keep in mind is Delta Live Tables require premium plan. We are already working with premium plan. So if you're working with a standard plan, you need to upgrade to premium plan to work with DLT. Now, we cannot complete the whole Delta Live Table session in a single video. So we are going to cover Delta Live Tables in next 3 or 4 videos. So today's video is all about the introduction to Delta Live Tables. Now, before we can start with Delta Live Tables, if you have not seen our previous video, I would recommend you to go back and watch them first. So, without any delay, let's begin. I am in my Databricks workspace. I have already created a folder called 02 DLT Pipelines under the workflow folder that we have created previously. Now, if I expand this, we are going to work with 2 notebooks today. The first notebook is a set notebook that we will use to set up some of the tables for our DLT. And the second notebook is the exact notebook that we will use to write our DLT pipeline. So let me just get into the first notebook. Our compute is already up and running and connected to this notebook. Now, the first cell is to create a new schema called ETL under the catalog dev. And we are going to use the schema for all of our DLT run today. So let me just quickly run this cell. Okay, it says okay. So let me just expand on the left hand side. And now you can see a schema created called ETL. It is currently empty. So we are going to use this for our DLT processing. Now, the next thing is we will need some data in order to work with our DLT pipelines today. And I'm going to do a deep clone from the samples which are already provided by Databricks. So you can find the samples on the left hand side here. So the samples is from catalog samples. There is a schema called TPCH and we have tables like orders and customer. And we are going to create a clone table under dev branch called orders raw and customer raw. And we are going to do a deep clone. So let me quickly run this. While this is running, if you are unaware of deep clone, you can go ahead and check out this video. Awesome, completed, right? So let me just expand on the left hand side, expand the tables, and now you can see the customer raw table here. If I scroll down, you can see the orders raw. Okay, so let me quickly do select star from both of the table. Great, we can see the data. Let me quickly do it from customer as well. Nice, we can see the data for customer as well. Now let me just quickly duplicate this tab. So I'll duplicate it here. And now we will switch back to the DLT introduction notebook. Awesome. So this is the notebook that we will use for our DLT pipeline today. Before we start writing our code for DLT, we need to know that DLT uses 3 types of data sets. The first one is a streaming table, which can be permanent or temporary. The second one is a materialized view, and the third one are plain and simple views. Now, the first one, which is streaming table, usually have support for streaming, and it is also used to process incremental data. Now, it also allows you to append data into a table. The second one, which is a materialized view, is generally used for transformations, aggregations, or for computations. And the third one, which is a view, it is generally used for intermediate transformations, which are not stored at the target schema. And one more thing to keep in mind is DLT pipelines are powered by Delta Lake. So you get all the capabilities of Delta Lake while working with DLT pipelines. Now, it might sound confusing for the very first time, but we are going to understand each one of them with examples today. Now, we can write the DLT pipeline code in 2 languages. The first one is Python and the second one is SQL. And we cannot use the all-purpose compute to trigger our DLT code. That requires a special type of job compute for which we have to create our DLT pipeline. Okay, so the first thing that we are going to do is we are going to write the code in this notebook and then we are going to create our DLT pipeline for executing this notebook. Now, in order to work with DLT, the first thing that we need to do is we need to import the Python module called DLT inside this notebook. Okay, for today's demonstration, we are going to use the clone table orders and the clone table customer, and then we are going to join both of them to aggregate values based on market segment. So the first thing that we are going to do is we are going to read orders as a streaming table and customers as a materialized view. Okay, and both we will read from the clone table that we have just created. So in order to create a streaming table, we will use a Python decorator called @DLT. Now, in order to create a table, we need to use the notation .table. Okay, now within brackets, you can specify some of the properties. For example, if you want to specify a table property for a DLT, you can just go ahead and write table properties. Okay, and you can use a dictionary to specify any table properties that you want. For example, I'll just specify quality for this table, which would be bronze. Okay, and also I'll add one comment, which is this is orders bronze table. Okay, so this is how we specify the properties for a DLT table. Okay, now since this is a decorator, we need to define a Python function which will return a data frame which will contain the transformations that has to happen for this DLT table. Okay, so let's just write that Python function. To do that, I'll write df and the name of the streaming table. So we'll write orders bronze. Okay, and this should return a data frame which would be the transformation that would be applied to create this table. Okay, so let me just write return, and we need to return a data frame here, right? So let's go ahead and read our orders table that we just cloned. So I'll write df equals to spark dot. Now since we are creating a streaming table, then we should also read a streaming source, right? So in order to read a streaming source, we use read stream, and we need to read a table, so we'll write dot table, and we are going to read the clone table. So I'll write def dot branch dot orders raw. Okay, now delta tables has a property to work as input source for both streaming and batch mode. Okay, so this is a delta table which we are taking as an input as a streaming source. We are using read stream to read it, and this is why whatever table that will be created out of this transformation would be a streaming table. Okay, now since we have already created a data frame df, let's go ahead and return this. So I'll write return. So what will happen is, this is the transformation that will be applied to create this table. So the name of the table would be orders bronze, and this would be the transformation. So what would be the transformation? So the transformation would be to read a streaming table which is orders raw. So we have just written our first code to create a streaming table. Now if you don't want to specify the name as order bronze, you can go ahead and add one more value here called name, and you can specify whatever name you wish. For now, we'll just keep it as default. So if you don't specify any name parameter here, by default the name of the function would be the name of the table. Let's go ahead and create our materialized view for customers. So what I'll do is I'll quickly copy this whole code, and I'll scroll down and I'll paste it here. Okay, so in order to create a materialized view, we will use the same code, but this time our source will not be a streaming source, rather it would be a batch source. Okay, so we will use the same code. So we are going to use a decorator called DLT, and we are going to use dot table. The table properties for quality will still be bronze, but this time it is customer. Okay, now the name of the table would be customer bronze. Now suppose we don't want to specify the name here, we can go ahead and use the name parameter. So let me just do it. So I'll write name equal to customer bronze. Okay, and I'll just change it to cust bronze. So what will happen in this case, the name of the table will be customer bronze, not cust bronze. Okay, and in case of materialized view, the input source is a batch, not stream. So I'll just remove the stream from here. So we will use spark.read.table, and our input is the customer raw. Okay, and this will create this data frame which we will return. So the transformation is the read table, and the table which will be created with this would be a materialized view. So now you understand the difference between a streaming table and a materialized view. So in case of a streaming table, input will be a streaming source, but in case of a materialized view, the input would be a batch source. And there is a very big difference between streaming table and materialized view that we are going to see when we run this pipeline. Okay, so let's just hold the difference for now. So let me just scroll down. Now what we are going to do is, since we have already created our streaming table and materialized view, we are going to read them and we are going to join them. And now to do that, we will use a DLT view. So what I'll do is I'll quickly copy this code from here, and I'll scroll down and I'll paste it here. Now I'll remove all of this. So I'll remove the name from here, and I'll remove the table properties, because views are something which are temporary. It will not get stored at the target schema. So we just need to change the name here as well. So I'll write joined view. Okay, because we are going to join both customers and orders table that we just created in the top. Okay, and I'll change the comment. So what I'll write here is, now what we are going to do is we are going to read both the streaming table and the materialized view we just created. Okay, so the first thing that we will do is we will change the name as df_c, and we are going to read the customer materialized view that we created. And in order to read a materialized view that is being created in the same pipeline, we use a keyword which is called live. Okay, and the name of the customer table is customer bronze. So I'll just copy it from here and I'll paste it here. Now we are going to read the orders as well. So I'll just copy this and I'll paste it here, and I'll change it to df_o. And since we are going to read the table which is being created in the same pipeline, the name of the table is orders bronze. So I'll copy it from here. So we will use live.orders bronze. Okay, so we are creating two data frame, which is df_c, df_o. Now let's join both of them. So I'll write df_join equals to df underscore o dot. All right, join. And we are going to use df underscore c. And the first condition, which is how the join is going to happen. So the join is going to happen as left outer. Okay. And the next is on, in which condition it is going to happen. Okay. So the condition is df underscore c dot. So let me quickly switch back to introduction and let me scroll up. So the name of the key is c underscore cush c. I'll copy this. I'll go back to I'll paste it here. Okay. And we are going to use double equals to, and we are going to write df underscore o dot. We'll quickly go back to the setup. We'll scroll up, and this is the name of the column. So I'll copy it, go back, and I'll paste it. Okay. So our joining condition is ready. So let's go ahead and return this now. So this is our transformation that has to be written. Let me just change this to view because we are creating a view here. Okay. So this would be DLT.view, not DLT.table. DLT.table would only be used to create streaming tables and materialized view. And we are going to use DLT.view in order to create a view. Okay. Great. Now that we have completed the join, let's go ahead and create one more materialized view on top of this and add one extra column in it. Okay. So what I'll do is I'll quickly copy the table command from here, which is for materialized view. I'll scroll down, I'll paste it here. Okay. This time the quality is silver because we are already joining data sets. This is no longer a raw data set. Okay. And I'll write joined table. Okay. And the name is joined silver. Okay. And I'll let the name be joined silver. Okay. Now we are going to read the view. So the name of our view was joined view. So we are going to use the same command, which is spark.read.table. But in order to read a view which is created in the same pipeline, we will use live dot and we'll paste the name of the view. Okay. And now we are going to add a column. So we will use with column, and we are going to add a column called insert date. Okay. And the value would be current timestamp. Let me quickly go ahead and import this. Okay, great. Now that our joint silver table is ready, let's go ahead and write our gold table, which will be based on aggregation on market segment. So I'm going to copy this again from here and I'm going to paste it here. Okay, now our quality of the table would be gold because we are going to do aggregations. Okay, now I'll let the name of the table be the name of the function. So I'll remove this from here and I'll change this as we orders aggregated gold. Okay, and we are going to read the table which was silver. So I'll just copy the name from here and I'll change it here. And now we are going to do some aggregation. So we'll write df underscore final is equals to df dot group, and we are going to group by on market segment. So I'll copy this, I'll paste it here, and we are going to aggregate. So I'll write AGG and we are going to count orders. So I'll write count, and what we are going to count? We are going to count order keys. So I'll just paste it here. Okay, now I'll alias this. So I'll write alias, and this is sum of orders. Okay, so this is our final. Let's go ahead and add one more column to it, which is for current timestamp. Okay, so after the group by is done, we will add one column called insert date into the same final. Okay, so let me just go ahead and copy this and let me go ahead and return this. Okay, so now our code for the whole DLT pipeline is ready. So what we are doing is we are reading two of the tables, which is orders and customer. The next thing what we are going to do is we are going to join them using a temporary view. Then we are going to add a column at the silver layer called insert date, and then we are going to aggregate based on market segment. So our code for the whole DLT pipeline is ready. Now let's go ahead and create our first DLT pipeline. Now, in order to do that, you can just go to the left bar, you can click on new and you can select DLT pipelines. Now, you can also scroll down and you can find the DLT pipeline options here. Sometimes it is also referred as ETL pipelines in Databricks. So if you don't see DLT pipelines anywhere and you see ETL pipelines, it is the same DLT pipeline. So now what we'll do is we'll click on create pipeline. Now, the first thing that we need to do is give the name of the pipeline. So what I'll do is I'll write 00 DLT introduction. You can give it any name, but I'll keep the name as same. Okay. Now, if you see the product edition, so let me just click on the drop down and you can see three options here: core, pro, and advanced. Now, in core, you can use the basic functionalities of DLT. It means you can read streaming tables, you can create materialized view, you can do aggregations. But what you cannot do is you cannot do CDC. You cannot do data quality. Okay. Now, if you go to Pro, you can do CDC, which is the change data capture. You can create SCD type of tables, but you cannot do data quality. Now, if you use advanced, you can go ahead and do every stuff that is possible with DLT that Databricks offers. Okay. For now, since we are not doing any data quality, neither we have written code for CDC, we are going to use core. Okay. So let me just keep it simple. Now, there are two pipeline modes. The first one is triggered and the second one is continuous. Continuous is used if you are using this pipeline in streaming mode. It means this pipeline has to run continuously without stopping. Triggered is it will trigger as per the schedule that you set. For now, I'll keep it as triggered. Okay. I'll scroll down and this is the path where you select your DLT notebook. So let me just select this. Let me click on users. Let me go to the folder. Let me go to workflows, DLT pipelines, and let me select DLT introduction. Okay. Now, if I scroll down, I get two options. So we are going to use Unity catalog. So I'll click on Unity catalog and we have our catalog already created, right? So we are going to use dev. Now, if you have not created any schema, you can specify the name of the schema. DLT will automatically create a schema for you and will put all the artifacts within that schema. But since we have already created our schema called ETL, we are going to use that. Let me scroll down. Now, we are not going to use any cluster policy and we are going to use fixed size. Okay. The number of workers that I need is 1. Okay. I'll not enable photon acceleration. And if I scroll down, you get more options. The channel option, let it be current. The preview has more options about the new upcoming features, but we are going to use the current one. Now, you can go ahead and add configurations. Now, this add configurations is used to pass in some value within your Delta pipelines. And this we are going to see in our next video. Now, let me go ahead and select the worker type. So what I'll do is I'll drop down and I'm going to use DS3 V2. Okay. And I'll let the driver be same as worker. Okay. Now, it already gives me how much DBU it is going to cost. It is going to cost me 1.5 DBU per hour plus the charges that Azure is going to take for the VMs that we are going to run. Okay. Let me just go ahead and click on create. Awesome. We just created our DLT pipeline. So this is the name of our pipeline. And now you see a lot of different options. Okay. Two important options on the top is development and production. Now, this is very important. The reason is if you see this development is checked by default. It means our pipeline is going to run in development mode. Now, what this development mode is, it means even if our pipeline is successful or it fails because of some error, our cluster that is running in the background will keep on running in development mode. Okay. But if the mode is production, as soon as our pipeline either it succeeds or it fails, the cluster that is created in the background will be killed. Okay. But in development, the cluster will be up and running for you to use it for debugging purpose. If our pipeline fails, we can attach this DLT pipeline to our notebook and we can debug it. And this is where the development mode is helpful. Other than this, you get a lot of different options like settings. In this, you can go back to the settings that we have already configured. Let me go ahead and click on cancel. And the one that is schedule, you can go ahead and schedule your DLT pipelines. Okay. Now, if you see on the bottom, you see pipeline details and update details. And we are going to see this when we run our DLT pipeline. So let me just quickly go ahead and click on start. Now, if you see, it is waiting for resources and there are some different steps like initializing, setting up tables, and in the end rendering graph. In the bottom, you get the events that is going to happen in this DLT pipelines. Okay. So this is how a simple DLT pipeline job looks like. Okay. So it is right now waiting for the resources to be up. It means it is now waiting for the cluster to be spinned up. So let's wait for it to run. So I'll pause the video for now and I'll come back when this is up and running. Great. Now if you see the cluster is up and running, that is why it has moved to initializing step and the waiting for resources step has completed successfully. So let's just wait for other step to complete. Okay, now if you see it has failed at the initializing step. Now, how do we need to debug? So we'll scroll down the event log and we can see here it says failed to resolve flow order aggregated gold. Okay, so let me just go ahead and click on this. And now you can see the error. It points out the count is not defined. Okay, because we have used count in the aggregation, but we have not imported this. So what I'll do is I'll quickly duplicate this tab and I'll go back to workspace, to our notebooks. Okay, and I'll scroll down. And what I'll do is I'll quickly change the code. So I'll import the count as well. So I'll copy count here and I'll just import it along with current timestamp here. Okay, so what I'll do is I'll go ahead and click on start again. So if you see now, it will quickly run because it will not have to wait for resources anymore. And the mode is development. And this is where it is useful for debugging issues. Again, it has failed. So let me just go ahead and click on this. And it says C order key cannot be resolved. Okay? Because the name of the column is O order key. So let me just go back and again fix this. So I'll write O dot order key. Okay. And I'll go back and I'll again click on start. And this is where the debugging is very easy if your DLT pipeline is running in development mode. And now you can see it has moved to setting up tables. This is where it will validate your pipeline and it will try to set up the DAG which is required in order to process this DLT pipeline. So let's just wait. Now you can see the pipeline here. Okay, so let me just quickly zoom in and I'll shut down the right hand side. And now you can see the complete pipeline. Okay, it is reading customer bronze, it is reading order bronze, and it is joining with the help of view. Then it is creating a materialized view for joined silver, and finally is a aggregated materialized view. And it has just completed the customer bronze. So it has read 750K records for customer bronze. And let's just wait for orders bronze to complete. It has read 7.5 million for orders. Okay, so now if I scroll to right, in this phase it is just an intermediate transformation, so it will not store any data anywhere. Now it is running the joint silver materialized view. Great, the pipeline just completed. Okay, in this case you can see it says completed here, and it gives you 7.5 million records at the joint silver materialized view, and the orders aggregated gold table has only 5 records because that is based on the market segment. Okay, awesome. Now that we have completed our data load for gold, let's go ahead and terminate our DLT pipeline. So I'll go back to compute, I'll go to job compute, and I'll stop the cluster that we are running. Okay, the cluster is terminated. So now that we have terminated our pipeline and our data load is complete, I'm back in my setup notebook. So on the left hand side, let me just expand dev and ETL. Now you can see a lot of data sets inside it. So let me quickly zoom. And now if I hover, you can see these are all materialized view. And orders bronze is a streaming table. So you can see the different symbols used for the different data sets. Okay, now let's zoom out a bit. And now let's go ahead and check the data for orders aggregate gold. So what I'll do is I'll write select star from, and I'll click on this arrow symbol and let me just run this. Great. Now if you see, we have different market segments and different sum for the orders. And we even populated inserted date for our aggregated gold table. Now, before I wrap up, you can see the view is missing. Only the materialized view and the streaming tables are created at the target schema because views are being used for intermediate transformations and that are not being recorded at the target. Okay. In our next video, we are going to see some background about this DLT pipeline. And we are also going to process some incremental data using this same pipeline. Till then, keep learning, keep growing, and keep sharing.